Hey, Antonio, welcome back.
Hey, Adam. Yes, back. I was in the podcast a few months ago, and now I'm back. It's like,
Yes, with some small injury, You told me that
uh,
is the most painful thing you can get is a
well,
destroyed toe, right?
yeah, destroyed toe with no nail, so that's why I had to cancel our meeting last week. I was,
Hmm.
went to the hospital, took painkillers, and I thought I can't go to Adam's podcast and
Hmm.
bleeding with my toe. So here I am, alive and kicking. Well, not kicking yet, but alive.
Just because of the missing nail, you get a painkillers. What's wrong with
Yeah,
you? I thought you are a Java developer, Java champions. Usually, Java champions, there is a contract, no painkillers.
no painkillers. Well, we have you and I have started Java many, 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 many years ago,
Yeah.
and we used to compile with Java C dash dash CP and put a huge class path with a lot of stuff before Maven or Ant. So yeah,
Yeah,
we
without painkillers. And,
without
and, and,
painkillers.
and, and you are actually wrong. It was just one dash, minus
Damn
CP.
it!
You saw?
I haven't done that for
No, I will cut
years.
it out. Cut it out. No
I'll
problem.
cut it out. Otherwise, I will lose my Java champion medal.
Yeah, you lose it anyway because of your painkillers and the nail. So
Yeah, I'm
we
so
also will
sorry
have to
about
cut
that.
it out. Cut it out. Uh,
So
uh,
sorry.
the most important question of the podcast: where is now the nail?
In the cloud.
Ah, okay. So you are nailless, no serverless,
Yeah,
nailless, Antonio.
yeah. We in the cloud, you can do serverless, and now you
Yeah,
can do nailless. Yeah.
that's perfect. So Java on Azure. Now to the main topic, right? So or side topic we can say. So um, I was I attended Java One, and what I remember is a booth, and with a huge banner, Microsoft loves Java,
When was
and
that? When was that? Which year?
it had to be 2013, 14, something like this, and it was the first time I remember that Microsoft was on Java One, at least so prominent, and it was in the near of the booth of IBM. That's also what I remember because I had a question regarding Open Liberty. So I went to the Open Liberty booth, and Open Liberty was new. And then I saw Microsoft, and I say, what they are doing there, with Microsoft loves Java and everyone. And I say, okay, now it's interesting. And I walk, from, and there was Erin Schnabel actually on Open Liberty, an IBM booth, because I had some questions regarding. Actually, I know what I ask, regarding how to make Open Liberty leaner, just to start, whatever you need to start, and then walk, to the Microsoft booth just to check out what they are doing there, right? And there was a Brian Benz, and Brian was the nicest guy. And I say, hey, what up? What's up? Years you told us, .NET is the thing to do, and J++ and all the disaster from 1997. And he was the nicest, and said, okay, we do Java and we don't care. And this is what I remember. And and you also know Brian, right?
Yeah, Brian Benz. So Brian Benz is a Java champion,
Was
and
it before or became Java champion at
oh, good
Microsoft?
question. Good question. I don't know about that. I don't have the answer, but I know that Brian Benz joined Microsoft in 2012, and he even wrote a blog about it. I'll give you the
Hmm.
link. And yeah, he says, I'm quoting him, and he says around 2012,
Hmm.
Java at Microsoft was seen as a rival because Microsoft was doing .NET, but then it became an amazing opportunity because now I joined Microsoft just 18 months ago. Brian has been there for more than 10 years, and why did I join? Because Azure is full on Java. There's 14 Java champions at Microsoft, for the last 5, 6 years.
13
There's
now, because one was, cancelled because of the painkillers. So, so you have 13 Java champions,
damn it. So yeah, definitely Brian Benz was the bravest. He arrived at a very, very early stage. He did a few conferences at the very stage of Azure supporting Java. Today we will talk about it, but there's many runtimes
Mhm.
supported in Azure. It's very easy now to deploy an executable jar easily in one command to the cloud. But at that time, it wasn't the case, and Brian was already doing conferences about this topic. Yeah.
So the 14 Java champions is like the Jedi Knights, right? This is almost like, it seems like, so you have everyone, you know.
Yeah, well, Microsoft, like Oracle, like IBM, has his internal, like MVPs and Microsoft valuable people or something like that. And Java Champion, as you know, is historically comes from Sun. So it's just external Java champions that were hired by Microsoft throughout I would say in the last 5 to 6 years, where it started to boom. And to be honest, when I joined Microsoft, I already had many friends, Java champion at Microsoft. I already had many friends doing Java at Microsoft, and I was wondering what was happening. And when I joined, I saw this amazing energy around Java on Azure. And my job is to help customers. So I have customers throughout the world who deploy applications to Azure. Either they start their journey in migrating from on-prem to Azure. Some of my customers already have been on Azure for years and need more. So my job is basically helping customers throughout the world who have Java workload, because our team has a .NET side and a Java side. And I only do Java workloads to Azure.
There was one guy, I forgot his name, famous one. I think he worked for Sun Microsystem and the Java Virtual Machine. Really nice guy. Or Sun or Oracle, but I suspect even Sun. And then switched to Microsoft and kept working on the JVMs. He attended all the JVM summits. You remember he was Java champion and he's still active. He was very involved, in the internal JVM.
Well,
at
the moment we have Martin Verberg.
Yeah, but this was prior. This was
prior.
He was very famous.
We also have Kirk Pepperdine.
Even earlier. So
Even earlier.
It was. I would have to look it up. I remember his name. Back then, it was a huge. Why he's doing that, and this was way before Azure. He switched to Microsoft and kept attending the JVM Summit conferences and contributed his knowledge, and he worked. So it was interesting. I will remember, because he's a really nice name, really nice guy, and he was really helpful. It was like something like around the Java puzzlers, this kind of
okay. But we have Eric Gamma, even if it's not on the Java side. But
that is the Eclipse guy, it's crazy. Yeah, why Java? He attended all Java conferences with the Eclipse. He also
But why do we have Martin, Kirk, and all these people? It's because now Microsoft has a Microsoft build of OpenJDK. So we support, Azure supports Java 8, Java 11, and Java 17 with our own Microsoft build of JDK. So Microsoft is part of the OpenJDK consortium, Eclipse Adoptium. We are there, and we even contributed. Well, the JDK team even contributed to port the JDK on Windows. So we have our own build of OpenJDK with monitoring functionalities for Azure, but we also contribute on the JDK itself.
So, but are you also deploying in your work, to Java to Azure, or just consulting with customers? So you are still hands-on hacking?
Oh yeah. That's companies like Microsoft, Google, all these companies. You can do a career being technical. You don't have to be a manager. I work and live in France, and I became a contractor 17 years ago to avoid being a manager, because most of the big French companies, once you reach a certain age, when you reach 30 years old, they turn to you and say, "Hey, you should stop developing. You should become a manager."
30 years? Okay, then I have still some years, to go. No problem.
So, I have a very, very technical job.
Cool.
I don't have to manage anybody. I'm so pleased about that.
That's cool. Then we can talk now a little bit about technology. So, all the possibilities you would run Java. I think the first one is the most boring one, or not boring. I mean, the most basic one would be to run Java on a virtual machine, or I mean, on just how to call it, on not bare metal, on virtual machine, not Java virtual machine, rather the virtual machine. So how you would do this, and what I'm interested in, Bicep. Now, I mean, you could do this because I had a attendee on my workshop, and they do it for costs, right? So they said in their particular case, it's cheaper, to hire or to rent a huge machine, and run multiple application servers is cheaper than have containers for just economic reason. So, and what I'm particularly interested in is Bicep, So, how hard would it be to use Bicep, to ship Quarkus on a virtual machine on Azure and see Hello World?
Well, actually, Julien Dubois, as you know, another Java champion.
Okay.
A couple of years ago, he created an open source tool called Nubgens. I will find out the URL for you, and it's actually very interesting. It's like a wizard, very basic, and you go, I have this app, it's running Spring, or it's running Quarkus, or it's running this and that. Please generate some Terraform or Bicep templates. And then he generates Biceps, and you go bang. Really, really easy. Noobsgen.com. I'm posting that on the chat, and it's because to be honest, when you're a Java developer, writing Terraform or Bicep templates can be a bit complex, and this tool, generates all these templates for you, and then you can customize them. It generates just text files, YAML files, and that's all. But coming back to your question, of course you can deploy Java on VMs, and the customer that you had, if they have chosen Azure VMs, that's maybe for a good cause. That's why we have several runtimes, but it's definitely not the easiest. As you know, if you have your own VM somewhere in the cloud, on Azure or other providers, you have to look after everything. You have to look into security,
but
network.
What I would do, I would just have all the possibilities. So I could actually run on a single VM, bind to a public IP address, and expose it via generated DNS name, right?
Yeah.
If I would like to have the nice DNS name, so I guess I would need a load balancer or something up front, right?
Yeah.
Okay, this is the first one and the most boring one, because you can install on VM whatever you like. And by the way,
and one of the most complex too, because all the security and the networking around the VM, you have to do it yourself. Of course, Azure will help you, but to a certain point. And deploying to a VM, when I arrived at Microsoft 18 months ago, I didn't know all the computes, Azure App Service, functions, blah, blah. And my first choice was, hey, I have a side project. Let's do an Azure VM. It was so painful. I'm not a network expert, and network issues were so complex.
So two painkillers, right? So two pills.
Two pills. The red and the blue. So yes, the most, I would say, basic one that everybody understands is a VM. But then you have to understand that you have to do a lot of work yourself. Yeah.
I found the name of the guy, Neal Gafter.
I think he's not part of Microsoft anymore.
Okay, but he was, right? Yes, so he was, and he joined Microsoft incredibly early.
Yeah.
And and Java programming. Okay. And this is interesting. Also, he joined Microsoft. He still kept working on JVM and attended JVM Summit and stuff like that. So it was interesting. Really nice guy. Okay. So now, this is the first one. So the next thing, which I really like, are Azure Container Instances, ACI.
Yes.
The simplest one, right?
Yeah, the simplest one. Yeah, I agree. ACI, Azure Container Instance. You have a container with or without Java. Mm-hmm. You push it to ACI, it works.
Yeah. To configure this, you need maybe 20 lines of JSON.
Yeah. Very.
But this is what I always tell my clients. They say, okay, what's about portability? It's like, okay, if I have to rewrite the 20 lines of JSON, I don't care about portability, right? So this is like then I will write for you the 20 lines and go somewhere else, because they say this ACI is not, it is I'm depending on Azure, and we have to use Kubernetes. Like, okay, then either we write 20 lines of JSON or 2,000 lines of YAML and then are portable, right? So this is the thing. Okay, interesting.
ACI was, I think, one of the first containerized services. Mm-hmm. When I joined Microsoft, we already had ACI, mm-hmm. but really, really quickly after I joined, there was Azure Container Apps in preview. Mm-hmm. And Azure Container Apps is Azure Container Instance on steroid, because ACI is for one container, you can't do much with it. It's very easy to deploy. But Azure Container Apps is a full-on manage a containerized environment. So you can have several containers. They can talk to each other. They can scale to zero, scale from zero very easily using Keda. So most of the time, you don't even have to do anything. It just scales down to zero automatically and scales up from zero, automatically. Of course, our customers can then customize it. But Azure Container Apps is not that old. It's more than a year old now. But it's if you have instances on Azure Container Instance, ACI, have a look at Azure Container Apps. Mm-hmm. Really interesting. And again, it's containers. So it could be, Java, Python, whatever.
Mm-hmm. And what I like about that, first, the pricing is serverless almost, because we are paying per virtual CPU second. So it is very similar pricing to Azure Functions or Lambda.
Yeah, exactly.
And what you said, Keda, it sounds like Kubernetes. So what I like about the service, that Kubernetes is working behind the scenes, but I don't have to care about Kubernetes. Yeah. So I have nothing against Kubernetes unless someone forced me to write the YAMLs, because I remember, my Xdoclet days where we try, to hide all the generated. It's like, again, really, do we have to do it again? So for me, Azure can use Kubernetes all the time behind the scenes, but I'm absolutely not interested, with playing with the YAMLs again.
Yeah.
So, and I also remember this. This was we almost used that in a project. The problem was the preview was not available for the premium SKU. I think where you have the special network requirements and stuff like that. But now I think it seems like it is released product. It's called Azure Container Apps. And what I assume is, so the problem with ACI was it was hard to have a load balanced app, which is, if it failed, it failed. There was one instance. And whereby the Azure Container Apps, I always confuse Azure Container Apps with Azure Container App Service. So you have to be careful. So when I mean Azure Container Apps, I mean the thing which runs on Kubernetes and behaves like ACI but is clustered. Yeah. That's what I mean, right? It is clustered, can scale to zero, right?
I think, when we introduced this buzzword serverless, I think we associated it to functions. And for a lot of people, serverless equals function equals serverless. Mm-hmm. But Azure Container Apps is a serverless runtime. We have Azure Functions, but as you say, it can scale to zero and you pay nothing. Yeah. You'll actually pay zero. So, and we have customers who are using Kubernetes for many, many years. They are comfortable with Kubernetes. So we have Azure Kubernetes Service, AKS. But we have customers now who are confident with containers. They have been containerized for a few years, but they are not confident with Kubernetes. As you say, some customers find it too difficult. Azure Container Apps, it's perfect. It's really, really perfect. It's the runtime I like the most. We have Azure App Service. You were getting confused with Azure Container Apps and Azure App Service. Azure App Service is really good if you have a jar file and you push it to the cloud.
Back to serverless. My observation. You're also a young Java EE and Glassfish guy, right? So, and
I love when you say young.
Yeah, you're young because you said, you're almost 30, and then you have the problem that someone will expect, that you will become a manager. So I also have the problem. I view years, we are all 30, and what do you do then? But as we were, in the 15s, so we will talk about Glassfish and Java EE and stuff like that, right? As we are teenagers, and what I recognize is that all of us somehow, without talking to each other, we share some, or at least is my impression, some specific, expectation. What should happen? What is the next step? And for me, the entire Java EE with Glassfish and whatever was, I just like, to build my business logic and don't bother with the plumbing. So this was what I really like all the years. So people suspected I worked for Sun or was sponsored by Glassfish, which was never true. I just wanted, to build my business logic and have vacations. This was basically what I wanted. I didn't wanted, to understand 50 runtimes in order to build Hello World. I was not interested in Whitefly, Glassfish, nothing. Just write a code and go home. And serverless is the same.
Yep.
So this is this is why I really like serverless, because I see in the pricing, and if I already see vCPU, this is great. So I just buy the CPU. And I really don't care about, all the networking, whatever. I just pay and done. And the cool story is it goes further, because I don't have to ship the operating system. If I don't ship the operating system, I don't have to patch it. So, and this is an entire cascade. So serverless for me means it should be called servers are not important mode.
Servers are not important.
Yeah.
Let's create a new acronym.
Yeah. So we have one acronym, I care about servers, and then I don't care about servers. And I'm in the camp, I don't care about servers. So and then serverless makes absolute sense. And you're right. And I think that the serverless, what it means is that you get consumption-based pricing. And this Lambda doesn't matter, the thing doesn't matter. You call something and you pay per call. And if you buy the server, and you can call the server how often you like. The problem is you are in charge of really utilizing the server. If you don't manage, to run the server on 80% of CPU, whatever, it is really hard to get your money back. Whereby here I can scale up and down, and I have peace of mind. I focus on my business logic, what I did the last, 15 years with Java EE, and now we are done, right? So I would say the serverless is, from my perspective, should be the default, unless, you have heavy load, whatever, and then we have to pick, the virtual machine or whatever we had before.
But I like your analogy. We develop business code and someone else develops Glassfish, JBoss,
exactly.
Name them. And that's that. That now that I'm on the other side and help customers doing crazy stuff, I can acknowledge the difficulty of managing network, of managing security, of managing monitoring. We are talking about distributions, but really distributed, multi-regions, etc. It is so complex. And I'm really happy to have services like Azure Container Apps, where you deploy a container and the entire structure, and as you said, there's a Kubernetes underneath, but I don't care.
Exactly.
And so that's why we have all these compute runtimes. We were talking about VMs, ACI, AKS, Azure Container Apps, because depending on the level of management that you want, you can either do everything yourself with VMs, or do nothing basically with Azure Container Apps.
What also interesting is that the entire Kubernetes was hidden on purpose, right? So they say it is not necessary to know about Kubernetes. We are using Kubernetes. How it was actually meant. So I had a chat with Kelsey Hightower on the podcast, and he also said, Kubernetes was never supposed to leak. It was
interesting.
It was. He said, the YAML. It was never meant that you write the YAML. It's actually so. It was. It is a platform to build platforms, and this is done the right way in Azure Container Apps.
And sometimes we even have customers who come from the Kubernetes world who want to move to Azure Container Apps or move to Azure Container Apps, and the first question is, can I hack something underneath in Kubernetes to help me doing something? And the answer is no, you can't. No, but I want to, I want to open up the engine and put my own tools on top of it. No, you can't.
Yeah, and SSH also not possible, right? So I say, okay, and you could also, it's not impossible, I guess, to recompile the Linux kernel, right? So what I remember, I was a consultant, and a guy on the left side, I exactly remember, he had a Linux distribution, and I forgot the Linux distribution, but he had to build, the entire thing from source code, and it ran for days. And I say, why are you doing this? The machine went crazy. And it's like, yeah, but I get the best optimal, I don't know what, best optimal solution for my Linux. He couldn't work for 1.5 days. Everything was hot. And he said, like, why you don't do it this, right? So why you not optimize your Linux? It's like, if I look at you, I'm not really interested to have the same pain. I think he had at least, 5 painkillers, after 5 days. So he managed to compile his Linux, but I forgot the distribution of the Linux. And this is the attitude, I would say, in specific requirements, right? You have to have access to the machine, but then you use, I would say the architecture can be black or white. So if I write business code, I use serverless. But if I need to to talk to a very specific GPU, I wouldn't use serverless. I would buy the machine and talk to the GPU.
We also have we are talking about computes like Azure App Service, Azure Functions, Azure Container Apps. But then we have also plenty of customers who want to just do a rehost. So that's why Azure supports Tomcat, WebLogic, WebSphere. We have a lot of customers using WebLogic. We have WebLogic on VM and WebLogic on AKS. Mm-hmm. And basically, they have workloads working on-prem on WebLogic. They don't want to touch them. It's part of their legacy. One day it will die. And they just want to rehost in Azure. So,
yeah. But you are too fast, Antonio. What I wanted now to ask you is the next service, web app for containers.
Web apps?
Yeah, for containers. Yeah, what? Yeah, you have to say something.
Web apps? Well, are you talking about Azure Spring Apps or?
No, Azure Web App for containers.
Okay, so Azure Web Apps is for the client side. Mm-hmm. So that's, typically today we have a front end and a back end. The front end, you put whatever you want, Angular, React, or whatever. And on the back end, we have Java. And you can host everything in Azure Container Apps if you want, because it's just a container. But yeah, we have Azure web Apps that it's optimized for web applications. Why? Because the static content, the CSS, the images, etc., can be deployed on CDNs if you want, can be multi-regions, can be closer to your your users, while the backend can stay on the same.
What I did in the past, I used, I think, Azure Blob Storage, and you can expose the Azure Blob Storage as a website. This is what I did. There was also nice, like an Explorer, so I can push the apps there. And it seems like this web app for containers is more integrated solution with CI/CD and everything. But I think behind the scenes it still uses Blob Storage, right?
Yes, underneath, no matter what you deploy, a container, a file or whatever, of course there's some Azure storage underneath. Yeah.
Mm-hmm. Yeah, that's pretty cool because this we had the Azure Container Apps already. We had the web apps for containers would be the front end, so we can host, for instance, Azure Container Apps. We could host Quarkus on that, and the front end web components would be in web app for containers, for instance. Azure Container Instances is like the lightweight solution without clustering.
Yeah. Yeah.
Azure Container Registry, you need it everywhere because this is the place where the containers are pushed. So all the solutions will need this, right?
Yeah, or you can leave them in Docker Hub. If if you have your own image hub,
Yeah.
you can still use your own. But yeah, we have Azure Container Registry, which is our Docker Hub kind of
But
style.
usually you would use this ACR because of Docker throttling or whatever, right? And for companies, you've built something more, I would say, serious. Usually, we always go with ACR, Azure Container Registry, ACR. Exactly. There's something interesting, Azure Service Fabric.
Yeah, I don't know about this one.
Yeah, no
I don't
problem.
know.
You have to find it out, until you are 30. But if you become 30, it's over with programming. We already said. So this is this one. I also never used that Azure Service Fabric.
Yeah.
Looks interesting.
It's also a service to build scalable microservices, etc., etc. But
with Quarkus, you don't need it. If you have a runtime which is bloated, maybe. But if Quarkus is lean and fast.
Lean and fast.
Lean and fast. This is exactly how we are. So, okay. So, Azure App Service now.
Yeah.
The Azure App Service is one layer above, right?
Yeah. That's the Azure Container Apps. Brilliant, perfect, fantastic for containers. And now we have. Before, Azure App Service is way older than Azure Container Apps, and that's, you can deploy several kind of artifacts, but the easiest one is you have an executable jar file like Quarkus or Spring Boot, and you go to Azure App Service, you deploy your jar file, you have a list box saying run on Java 8, 11, or 17, and you're done. There's nothing to be written, no containers, you don't have to deploy anything.
It is almost like Azure Function, which runs all the time, right?
Yeah.
And so how hard would it be, to have a main method which just opens a socket, just without Quarkus, without nothing. It's just Java 17, let's say. And we ship it, and it calls a main method. This would be also doable, right?
Yeah, and plus we have a few CLIs. We have Azure CLI. You can create resources. You can deploy stuff. But now we have Azure Developer, the AZD CLI. So we have one CLI, that Azure CLI. This is for ops, and AZD for developers. And you can. We were talking about Azure Container Apps. You have AZ Container Apps up, and it creates everything. It creates an Azure Container Apps environment. It creates a registry. It creates everything. Pushes your Docker image and runs it. Same for Azure App Service. So it can be very, very easy to deploy. Hello worlds in a few command lines. Of course, when you run in production and you have pipelines and secrets and writes and Azure Active Directory and so on, that's another level. But it's very easy today to deploy Java workloads on Azure with just a couple of command lines.
You already mentioned this, but I think we covered everything but not Kubernetes, right? AKS, of course, is available.
Yep.
If you have time to write YAML, you can, of course, use Kubernetes, right?
Yeah. AKS is, we have a lot of customers on AKS for different purposes. One interesting purpose is what you're saying. Remember the good old days when we had a WAV file and it would run without too much change and too much pain on WebLogic, on WebSphere, on JBoss, on Wildfly. Well, same thing with Kubernetes. We have customers who have Kubernetes on-prem, but they want to go to the cloud on Azure, but also on AWS or Google Cloud Platform, and they find that the Kubernetes is the Esperanto platform to deploy, because a lot of customers still keep on-prem servers, and they want to deploy the same artifact on-prem and on Azure. And Kubernetes is a perfect fit for that.
This is what I don't understand, because of our client, they have on-premise and high availability solution, and it runs actually on Docker Compose even with HR proxy, I think. It runs for years, several thousand transactions per second, and they are happy. Now, and Docker Compose is Docker. If you take a look at the Docker, I could actually start it on AWS on Fargate, but I don't see, and without any modification, I could run the same Docker on ACI or Azure Container Apps. So it means, without Kubernetes, I get the same, because what the Esperanto of all the clouds is, how to call it, container orchestrator. You will need a service which monitors your container, and liveness and readiness probes are available even in ACI. So in ACI even expects you to have liveness probes. So the container is getting to be restarted, and you need a kind of load balancer, and this is all you need. And if you actually use Kubernetes, the problem is that the load balancer is not a part of the Kubernetes, so you get a different load balancer in every cloud. So what I'm just saying is, what my feeling is that the some managers don't understand that there is a cloud without Kubernetes.
Yep.
And the cloud without Kubernetes is actually a great cloud. It's a simpler cloud. And for me, it's there are two possibilities, right? Portability or switching costs. Portability means without any changes, I can actually, push the same app to multiple clouds. So the question is, how complex is the portability? How much time do I have to spend to test to achieve the portability? Or switching costs, If I have to write 20 lines of JSON and am able to switch between ACI and Fargate back and forth, I don't care about portability, because I will spend 2 hours and I can migrate my small app back and forth. And larger apps, I spend more time, with networking regions. The regions are different, the IP addresses, the security in each cloud is completely different. So I would say the migration costs from cloud to cloud are not necessary, to migrating the container, rather than, adopting the infrastructure, certificates, secrets. This is where you spend, days, but not moving the container around.
But it really remember the good old days where we had WebLogic administrators and WebSphere administrators. Those people were, rocket science in every little detail of WebLogic and WebSphere. And then Spring Boot came saying, hey, this is just a jar file. Yeah, but how do I customize it? Yeah. How do I administer it? And Spring Boot, it's not my job. And I think it's the same thing. We have customers moving to AKS because they have years of expertise in Kubernetes, and they are really expert in Kubernetes. But maybe it's a phase, maybe, I don't know how many experts of WebLogic there are, in the market today, but definitely less than 10 years ago. And maybe the same thing will happen when I see Azure Container Apps. I love it. It's amazing. It's amazing how simple you can deploy a container, and it does all this complex stuff that you don't know how it works, but it works.
The interesting part is I get often hired, to help my clients with Kubernetes. And I say, okay, before we do Kubernetes, I show you what we will have to do to get Kubernetes. And I've showed them, I say, okay, this is not as nice as we thought, right? So, and then, and then they ask me, what you would do, right? It's like, look, there are nicer, smaller services. I say, yeah, but I'm not then depending on Azure, or I'm depending on AWS. It's like, yeah, but the dependencies, there's so much code. And then they start to understand that they are dependent anyway. I mean, because they are depending on contracts, on the direct line express route between Azure and the backend, or in direct connect on AWS case. And it really, I would say simplicity is the key. But this is, I'm pretty sure. And if you even look at the conferences, my impression is that the Kubernetes is less and less, interesting. So there are less and less talks about Kubernetes. It's just no one talks about Linux. Everyone uses, but who cares, right? So
exactly.
Remember,
like everybody, it comes to the electric plug. We don't care about the electricity. We know it works, and I'm sure Kubernetes will become, something that we don't want to know about. We don't want It's there, thank God, but we don't want to
Yeah, it
play
moves
with it.
down
It
the
just,
stack. Yeah.
yeah.
Remember the guy Alexis Pushkin?
Puskin, yeah,
Remember him?
of course.
Yeah.
I still see him. He's still a friend. He lives
Yeah,
next door.
and greetings to him. What I remember, Java 1, he came to me and say, hey, Glassfish v3 is modular. And I told him, why? I mean, this is crazy. DV2 just worked. Who cares about your modularity, you know? I don't care whether you start 5 modules or 20. I just push my war, and if it starts fast, I don't care what you're doing inside. And this is what you said, there are two sides. I was always, the user of these services. And for me, convenience was important. The Glassfish v2, it just started. Then it started. The Glassfish v3 started half, and then I wanted to have an admin console. I had to wait again until, the module for the admin console wakes up and starts. And everyone, this is exciting now, lazy loading of the container. And I was like, this is a crap. I would like to start everything. I know every time I need the console, right? Why I have to, and this is actually the interesting part. If you are a user of technology or you're implementing the technology, usually, you don't understand each other because they are complete different concerns. And from their perspective, from Glassfish internal perspective, was crucial to have modules because you cannot develop easily a monolithic code base. This was the problem from them. From the user perspective, a monolithic code base is perfect because, like a Quarkus, you have one jar, it starts. If Quarkus will ship, with 50 jars, I would say you're all crazy. I mean, this is like we had it in Java at the GDK 1.0 time frame. This is a no improvement. And I would say monolithic thinking is good for user experience, but it's a problem to develop such a thing efficiently, right? And this is what I like. For instance, the Azure App Service or the Azure Container Apps. This is convenient to use, and I don't care about the modularity of Kubernetes. Then I could replace every service because I don't like replace every service. I have other problems.
Yeah.
So this is what I think. But if I would be the engineer at YouTube, completely different story. If they're running the entire thing on Kubernetes, then replacing a service, be able to replace a service, and to achieve 0.5% improvement can save us a huge amount of money, resources, energy, whatever. But this is not my world. I still building create, read, update, delete to a database most of the time.
No, the interesting thing with my job is I see different customers with different needs, different workloads, different. And it's true that I was talking about WebLogic on AKS that we support. JBoss EAP, we have a partnership with Red Hat. That's, we have plenty of customers who are more than happy to leave a WAR file working from 1st of January till 31st of December. But we also have customers who want fast startup. When you are doing Azure Container Apps or Azure Functions and you have a Java workload, you want your VM to start as quick as possible. That's also why now, we see more and more Graal VM or Crack also. So we have a few customers who do care about the startup time and resource. Because, at the end of the day, we also saw this, how do they call it? Chief Finance Officer, 10 years ago, you had your own servers. You would pay them a fortune, but, you would pay them once and then run as many workloads as you could on that service. Now we're in the cloud. Everything has a cost. You can see all the costs of all your services, how much they run, etc., etc. So we do have customers looking to more and more into these costs and cutting down costs. And they need fast startup time. They need to scale to zero as soon as they could. So that's why, Azure has such a rich set of services, because we do have customers who either need a WebLogic to run 365 days a year, or something that starts very, very efficiently so it can go to Azure Functions or Azure Container Apps.
Before we cover Azure Functions, because this would be my next topic, you already mentioned OpenJDK. And It seems like Microsoft has an OpenJDK distribution, right?
Yep. It's called MS Microsoft build of OpenJDK. Yeah.
Very good, because someone asked me this and I say, okay, it is called the Microsoft OpenJDK, so I was not that wrong.
Yeah. It's and if you have SDK man, if you install your JVMs with SDK man, have a look. It's there.
And the MS OpenJDK, I assume, is free and is fully supported by Microsoft, so it's patched by Microsoft, right?
Exactly. And behind the scenes, when you have Azure App Service or stuff like that, it's also a JVM that it's monitored automatically. Monitoring is quite complex. That's what Martin Verberg and Kirk Pepperdine work on. They were, before they joined, they had the Clarity software to analyze VMs and code and stuff like that, and that's what they are doing. And that's what I was saying. When we have these distributed VMs all over, multi-regions, etc., to aggregate everything and have a single monitoring view, it's quite complex. So that's why also our JVMs are instrumented, so they can help you in monitoring.
One thing which I didn't did in the past, because most of my clients already have, Docker images with super images in the JVM. But assume I'm completely, greenfield, and I would like to ship Azure Container app. So just the container, not the service, the app. Is there already available, and let's say a blessed, fully supported Microsoft Linux super image, which you would say, pick this one, this is what we suggest, with installed JVM, because this would be a nice experience. You know what I mean? You say, okay, if you would like to do Quarkus, you can just pick the image. This is like whatever distribution it is. It is like battle-proof Microsoft Linux or Ubuntu or whatever you have, with MS OpenJDK, like a super image, because this would enhance the serverless experience by saying, okay, pick this one, and Java is already there.
Yeah, good question. I don't know the answer, to be honest, but I will have a look into it because it's quite interesting. When we do Quarkus, it comes with the Docker image and you don't look into it. When you do Spring Boot, it comes with its own Linux, etc. So I've never looked into that.
This would be a good job actually to be done, because what happens with the Quarkus, sometimes there are security issues in the UBI. Yep. So what you already had, I wanted to push it, and the scan was cancelled because they say, okay, there is some issue with that. And in production, I'm actually not allowed to do that, because no one knows when the super image from Quarkus is updated. So I always have to use something different. Now, either I create my own thing. So back then, I created a project called Docklands, but usually I prefer images from my clients. But it would be nice, if Microsoft would provide a super image and say, look, if you are if you're just a Java 17 developer, there's our image. We patch it and go for it. So this would be, it will, enhance the serverless experience, as I said. So, okay.
Yeah, true.
Now, interesting part. We covered now the OpenJDK, which is...
Sorry, we do have. Yeah, I just looked into it. Yeah, well, we do have container image for MS build of OpenJDK, you see. I'm going to pass it in the chat.
In the chat. And is there a specific name for it?
No, it's a container image for the MS build of OpenJDK. It's called the Microsoft build of OpenJDK.
Yeah, we should call it the Antonio distribution from...
Oh my God, no. Martin and Kirk, maybe not me.
They are managers, right? They are over 30, so they are not allowed to code anymore.
I think, I had this
They're still
joke.
hacking, right?
Yeah, they are. And there was... Last year,
maybe for the audience, because this is like here inside baseball. But the Kirk Pepperdine and Martin Verberg, Martin was very, or still is. He was very involved in the London Java user group community, and he was like all over the place. He was like the Java rockstar and champion on steroids.
Yeah.
And the Kirk Pepperdine, he was a really technical, and he always made this. What I remember. The Sun engineers angry, right? He always found something, which didn't work or whatever.
Performance issues,
whatever. This was the Kirk, and they created a startup, and I always met them at Java 1.
jQlarity, yeah.
which try, to improve the performance with KI, also with KI is German AI, artificial intelligence. So with machine learning, some early machine learning stuff to improve performance. I actually had Martin already on the podcast, to talk about that. And they join now Microsoft. So this is the interesting part. Yep. And the OpenJDK we talk about, this is actually was created by them, you're saying.
Yeah. They have an entire team working on that. And I remember last year we went to JavaLand, this Java conference in Germany, and they had there was Martin and people from Oracle and people from Eclipse, on stage answering questions about the JDK and the different builds, etc. And I had a question to the crowd saying, "Hey, Martin, are you still a Java developer or C++ developer?" Because they do contribute to the JVM itself, so they have to contribute in kind of C++ somewhere, but then they patch our distribution. They make sure it integrates with Azure and so on. So Martin and Kirk are still very, very, very technical people.
JavaLand, I have to tell you a story, because as this JavaLand started, so they approached me and say, "Will you just pick at JavaLand?" I was like, "Well, what's the name JavaLand?" It's like, "This is great. This is Phantasialand." And I look at this. What is this? It's like, this is for kids. What are you doing? Yeah, after the talk, you can take a ride. I was like, "What a ride?"
Yes,
and they say the carousels, and I say, "I have no time." I just imagine, we meet at JavaLand, and they say, "Hey, Antonio, stop. We have to take a ride, with the I don't know what they have there." Or and I say maybe, but if our conference, I would just like to talk with people, whatever. I'm not interested in carousels. There are still rides you have to ride.
Yes, yeah. You can. I think I can't remember the days, but it was the second day on the evening. There was rides and everything. The JavaLand experience is amazing. The venue is fantastic.
So all these speakers and everyone just ride with the carousels there.
If they don't have a broken toe, you can.
Yeah, but without the nail, it's less ear friction. So you are faster then. If you have.
No, but it was very funny. After all the conferences, you have dinner. You can,
cool.
beers, etc.
After the dinner, a crazy ride. It would be really interesting. If the train is full.
Maybe before.
Maybe before. Very good. Okay. Now, Azure functions.
Yep.
Because I use them, they're really interesting. Because I use them with Quarkus.
Yep.
And what really surprised me, is the developer experience. Because if you would like to do this, you get an official Maven plugin from Microsoft. And I said, this is crazy. So Microsoft has a Maven plugin, and I use that. And what happens then? The entire infrastructure is created from the plugin. Quarkus creates the function.zip. Not function.zip. There's something like this. It is just a zip file. And then you get the function. Behind, I always forget, it's not API gateway, there's a different name for it, but the function behind becomes available as HTTP endpoint. So you can call it. Is it not, I forgot, what is the name? Is it the bus? You need a specific thing before the function, which listens to the HTTP events, and then the events are forwarded to Quarkus. And Quarkus just calls regular, the Java EE APIs. So I forgot the name. And the interesting part is, it is, for me, is very similar to Azure Container Apps, but it is always scaled to 0. Right? So after every call, it's over. The function can be warm and hot, and if you buy this for the enterprise, the premium SKU, it is always warm. This is the interesting part. And if you use the consumption plan, it stops. It starts and goes. So it is exactly. And for me, this is actually really interesting for specific enterprise projects, because you don't have to pay all the time. You just pay for what you use, and for specific project can be very cost effective.
And you were talking about the Maven plugin, and I was talking about the Azure CLI and Azure Dev CLI. The Maven plugin. We also have an Azure SDK. So we have an entire API. And something quite fresh and new, we've started contributing to Quarkus extensions. So we have Quarkus extensions for Azure for a couple of services. So you were talking about the Maven plugin. It's interesting that you mentioned that, because I really want to stress out how easy it has become to deploy a Quarkus app as an Azure function, a Quarkus microservices into Azure Container Apps, Spring Boot, whatever, even a WAR file, even an executable jar.
Yeah, Spring Boot is way harder, but Quarkus is easier, right?
Because with all this tooling, we have Maven, Gradle plugins, we have CLIs over the place, and I'm not even talking about VS Code that has a fantastic, plugins to Azure in IntelliJ IDE2. So it became very easy to push stuff to the cloud.
It is really easy. It worked from the beginning, so it's good for prototyping. But my mindset in the cloud is different. So the problem I have in the cloud is to delete the stuff you created, right? So, and you create something from the command line, you have to exactly know what you created, because otherwise you will spend some time deleting it again. So I try to automate everything from the beginning. So what I did, for instance, with the Azure Container Functions, I used back then Bicep to create the infrastructure, and use the same name in the Azure plugin. And what happened then, the plugin recognized, okay, the infrastructure is there, and it just deployed Quarkus. So now this was my approach. So I don't like too much magic, because I would like to have repeatable environment.
Yeah.
And even if you push Quarkus with one command, but I have 5 Quarkus in multiple accounts, staging accounts, then it becomes complex.
Yeah.
So this is why what I really like is the Bicep. Because the Bicep is, if you compare it with Terraform, I don't know whether you had to use Terraform.
Yeah.
Terraform is I would say, maybe even worse than YAML from Kubernetes. You don't have to tell it. You are the official Azure, I know, but I'm just independent developer. So this is
Terraform is.
But the Terraform, in order to have a for loop, you are on the PhD level. You have to counter, and whatever happens, you have a kind of loop, and then you have to write 5 lines of comments. This doesn't look like a loop, but it is actually one, right? On if, also not easy, right? So, but if you manage, to implement for loop and an if, you are done, And no kidding, with Terraform, in some projects they have thousands of Terraform.
Yeah.
And if you take a look at the Bicep, it is not Java, of course, it's their own language, but at least it's a language. And I get really nice, syntax highlighting in Visual Studio Code, so it's well integrated. And what I like about that is also my approach, So if I go back then, if I use Quarkus, I really use Quarkus. Back then I used Glassfish, so I just wanted to use Glassfish. I was absolutely not interested in running hibernating Glassfish, because then I would go to Whitefly. Why I should do this, right? So, and if I go to Microsoft, so then Visual Studio Code is from Microsoft. So I think for me the logical step is to use Bicep, because I already have the thing. And if something breaks and go to Antonio, the chances are the highest. Then Antonio knows Microsoft and not strange open source tool from the outside. But then, wait a sec. The last thing is portability again. This is what I wanted to say. They say, but with Terraform, I could deploy everywhere. And this is complete misunderstanding, because if you search Terraform Azure App Service, and you search Terraform ECS Fargate, then you will find that the Terraform syntax is the same, but the attributes, the resource is completely different. So you cannot actually use Terraform and have multi-cloud deployment. This is technically impossible, to my mind. You need some kind of translator, whatever, and then we are talking about abstractions, and then I'm with you, then I go with Kubernetes. But you will still have to have, Terraform to deploy Kubernetes. So this is a never-ending story. But for me, it's not a problem to have on AWS, CDK, what I use with Java, and on Azure, I would use Bicep. And they are different anyway. So, but we are developers. Everyone knows how for and if works, and to learn Bicep, the challenge is not to learn Bicep, is to understand which resources you have to call. And you have the same problem with Java SDK, with Bicep, or with Terraform. Because to the audience, maybe, how all the clouds are working, the provisioning works via HTTP, right? So on your machine, open source tool is running, and they're calling, some APIs in the cloud to provision the infrastructure. And these APIs are independent from the tool, right? Terraform has to use the same API, Pulumi has to use the same API, and Bicep has to use the same API. So you have to know the API, and this is the challenge, to know which API is available on AWS and which API is available on Azure. And if you know them, then you are portable. If you don't know them, then Terraform won't help you. And this is a very common misunderstanding, and I don't know where it comes from, because in several projects I had, we have to use Terraform because of portability. It's like, really, what is portable, right?
Yeah, it's really interesting, talking about portability is one of those myths. And we all know that even in the Java EE space, your WAR, your ER would not be 100% portable from WebSphere to JBoss. It was just a myth. And as you said, the good thing with Java EE is you knew it wasn't portable, but you also knew that it would not cost much to port it. And I agree with what you were saying. Sometimes it's better to go with the right tool, Bicep on Azure, and go to the right tool on AWS. And the portability is just you spending a few extra hours to write some Bicep and write some AWS rather than trying to have this abstraction layer. Because we have customers on the Java space. We have plenty of customers with Terraform because it was older. It's older. It was there before. People are used to it. It's always the same thing. I've been using it for 5 years, and now you want me to move to Bicep. Sure. So of course we have plenty of customers who use Terraform. But as you say, if they want to deploy on-prem and on Azure and on AWS, the Terraform will look different. The syntax is the same, but the modules are totally different, of course.
But Terraform had its moments, right? Because you could use with Terraform with OpenShift and whatever. So you can use the Terraform for modules, but I'm just talking about public cloud. So, Terraform is a perfect tool for different purpose. But if I would like enough to portability between clouds, it is not achievable with Terraform. And the argument that the developers already learned Terraform is not an argument because, there's no even for and if loop. Every developer will understand Terraform in a few minutes if you show what happens, right? It's not like you need their secret knowledge to be able to understand Terraform.
At the end of the day, you started saying, we want a repeatable deployment. And, again, it's really nice to have a CLI when you are prototyping, when you are working with customers, when you are trying new things. It's very, very good in one line. You push something to Azure. And then when you go in production or you change environments, you want something repeatable. If you know Terraform, stick to it.
Yeah, sure. No change.
If you don't have any tool and you want to migrate to something, Bicep is the...
Exactly. So I'm just saying, if you start a greenfield project on Azure, I would just Bicep a go.
Yep.
And then if it doesn't work for you, just use whatever works for you. Are you actually aware of ARM templates?
Yeah, that's behind
exactly.
the scene.
And
really behind.
What's really is also very important to say is that the repeatability and multi-stage comes from ARM templates. And what it is hard to not hard to explain. It's a declarative approach which maintains your state in the cloud.
Yep.
And this is the difference to SDK. So Azure has a nice, Java SDKs for everything. So you could actually provision everything with Java.
Yep.
But this is imperative. So it means, if you will have to write Java code like if the virtual machine is not there, create one. If it's there, update one.
Yep.
But with ARM, you say I need the machine. Period. Yep. And Bicep is built on ARM. Now the difference to Terraform is Terraform also does that, but the state is stored on your machine per default. Yep. And if you would like to achieve something different, you will have to configure Terraform to store the state in Azure somewhere, Cosmos DB or blob storage or whatever. And this has to be done. And this, in my project, it was not always well understood, and developers started, and the entire state with the secrets and everything was on developer machine, and other developer couldn't work because the state was on the one machine. But whereby if you start with CloudFormation on AWS or ARM template on Azure, the state is already stored in the cloud. So this is important. Then it's really repeatable.
Yep.
Because this was a very common misunderstanding, but it's actually somehow simple, right? And regarding J2E portability, I would say the bytecode was portable. The problem was, like Hibernate and Eclipse Link, they behave differently, for instance, right? So different locking behaviors, or Whitefly, was more aggressive with closing the session. So, but I would say the portability was amazing, no? Yeah. For instance, we are migrating lots of old Java EE projects to Quarkus, and my clients are still amazed how easy it is. So it was actually, it was a huge success for the entire story, the entire Java EE. I told you already in one conference, I migrated an old Java EE code as AWS Lambda and pushed it to the cloud. I could do the same with Azure Functions, which I actually will do in autumn, and it just worked. It was identical code. This was actually one of the upsides, that Java EE was not that revolutionary. It was incremental development, and all the APIs remained the same.
Yeah. We all know the story of Java EE and a few dramas that happened, and unfortunately, it slowed down the platform. But yeah, as you say, now unfortunately there's a bit of package naming. You have to switch from Javax to Jakarta. But yeah,
after 20 years, okay,
Yeah, it's amazing how the APIs are still there. The entity still persisted the same way. Yeah, it's quite amazing.
Now, Azure Functions, the last one, because you mentioned GraalVM.
Yes.
And what's interesting is, I use GraalVM on Azure, but I'm not use GraalVM on AWS. And people ask me why. And if you go to the pricing table, you will find the answer. Because if you have the premium plan on Azure, you are paying for invocations and for memory. So it means if your Quarkus is smaller, you pay less. Whereby on AWS, there is no premium plan. It means if you need more CPU, you have to buy the CPU with RAM. So let's say if you would like to have one CPU, I have to buy 1.7 gigs of RAM. With 1.7 gigs of RAM, for Quarkus, I could actually cache the entire whatever, right? So, and it doesn't matter how much memory I consume actually. So this is the reason why on AWS I always go with the corrector. On Azure, I ask about the plan because there's a difference. I wanted to check, but it still remained the same. There's a consumption plan and the premium plan, and in the consumption plan you just pay for the execution. That's fine. This is like AWS. But some of my clients need the premium plan, and premium plan means the function is only available from local data center. And in this plan, you're also paying for memory. So it means in this particular case, it is way cheaper to use GraalVM or Mandrel, for instance, right? And and this is, for instance, the premium plan and consumption plan. This is interesting distinction because the consumption plan is on demand, and the premium plan, you get lambdas, which are already warm, which is really nice because then the lambdas, Azure Functions, because the Azure Functions here, they really compete with Azure Container Apps. This is a very similar model. They stay, the entire time warm.
There's one difference still between the good old JVM and GraalVM is monitoring.
Yeah.
Because as you know, the JVM is a 25 years old beast.
Yeah.
That tools everywhere.
Yeah.
The monitoring of the JVM is amazing.
Mm-hmm.
With GraalVM, you end up with a binary, so you've lost all the monitoring magic. Yeah. So that's why sometimes some customers slow down on GraalVM if they don't have this aggressive need for memory and startup time. They still remain on the good old JVM because they have all the monitoring goodies. Mm-hmm. So GraalVM is very interesting, but it's not all the cases. And now with Crack coming, arriving, maybe Crack in the future will become more advantageous than GraalVM. We will see, but maybe not in memory. Who knows? But startup time, you get the monitoring because it's the good old VM. The startup time could be as fast as GraalVM, maybe. The VM is optimized, warmed up. You don't need as much memory to optimize your code. Maybe Crack, could be something in the future.
I use already Crack. It's called Snapstart on AWS with Crack,
Yeah.
and it works perfectly. But the GraalVM people are also working on it, on GraalVM optimizations. And I had already chat with Thomas Wörtinger, and they say, okay, what they would like to have, to be better than the JVM. So they're also working on the performance. But I have a different problem with GraalVM, if you think about this. If I run, let's say, we already talk about the MS Linux from Microsoft, or the MS OpenJDK. So if I run the function or Azure App Service, let's say, and so if I use the Microsoft JVM, if it doesn't work, if it crashes, I can call Martin Verburg or Kirk Pepperdine at night and then say, hey, what's going on with the JVM, right? Yeah, I bought a Microsoft plan and I get stack trace, right? But if I run GraalVM, I need support from Oracle or from Red Hat. And this is what many don't understand. So it is actually not serverless. Because serverless means I just say, to Microsoft, give me your Java 17 and patch it for me. I don't care what you're doing. But if you use GraalVM, now you are in charge of patching, building, and you only have to know it. And if I mention this, I often hear a good point, right? Because they don't think about this, that this is your binary, you have to care about, and if it crashes, it's your job to find the problem.
One thing that is underrated, I think, on the GraalVM, which I really like, is the tree shaking, the closed world assumption, is we have a WAR file that is 500 megabytes.
You have such a thing.
We leave Maven, we leave Maven to pull hundreds of jars.
No, this is not our world. But for me, it was no dependencies. My wars is like you can deploy them on an Apple Watch.
Not if you come from Spring Boot.
Oh, okay. This is okay. This is a different, but this is not world.
But the interesting thing with GraalVM, if you don't think, if you leave the binary out, is they do what they call this closed world assumption, which sometimes can be quite aggressive. But they remove unneeded code. And in terms of security, that's quite great because you end up, instead of having millions of classes that you do not use, they get rid of all the unused code, even methods, and you just have this binary with only the code that you use. And I think, they should do that just with bytecode.
Sure.
I would love
but
to.
Quarkus does that. Quarkus does that because Quarkus calculates in the build extensions, the dependencies, and what the Quarkus can do if it starts, let's say you have application with lots of injected dependencies, right? And there's like an island of dependencies which is not used. So Quarkus won't start this. They say, okay, this CDI island is not used, like tree shaking, so I'm not starting this. And this environment is passed to GraalVM later, and GraalVM uses the dependency graph to calculate. So I would say Quarkus already knows what's happened, and Micronaut as well.
Yeah, but what's interesting with GraalVM is the code is physically removed.
Yeah.
With Quarkus, it's still in there.
Yeah.
That's why the binaries are small and the memory footprint also is small. But in terms of security, it's quite interesting because the log4j bug. I wasn't using this method. Just get rid of it.
Yeah. But then for serverless, what Kirk Pepperdine and Martin Verburg should do is, if you ship JVM, behind the scenes, Microsoft should be in charge of translate the code to GraalVM, because this changes, because they say, okay, I pushed the JVM and Microsoft translated this or the cloud translated this to GraalVM, and they are in charge of the GraalVM. The only problem is, of course, monitoring. But if I go, to the cloud, I would expect monitoring from the cloud and not my own JVM monitoring, should be also abstracted. So I think the future maybe is there is a pipeline and there's one, say, if you like, we can, translate, the JVM into native image. This is like, checkbox. You have the AZD minus gralified, right? And gralifier. And then you have your native image. This changes my perception. We say, okay, look, client, this is Microsoft. I'm out of this thing. And if you have problems, go to buy support from Microsoft.
Not there yet with Graal.
No, but this would be
with the JVM.
This would be serverless experience, no? Cool. I think we covered everything, right? Because Kubernetes is like, it is there. You could start it maybe once.
Adam, I can't believe you say we've covered everything. We are in 2023. If we don't talk about AI, we haven't covered everything,
Yeah, OpenAI, we would like to talk about.
No, but it's keeping the Java space. You all know GitHub Copilot. GitHub is from Microsoft. OpenAI and Microsoft have a very close relationship. But coming to the Java space, there is this brand new thing called semantic kernel, which now exists in .NET and Python. And the Java version will be coming soon in the next weeks. So
the first commit happened yesterday. Or 2 days.
Well, there's a branch.
Yeah.
There's a branch we've been working for a few months, but it's not in the main. But it will come to the main very, very, very soon. So just to say how fresh it is. So semantic kernel is something really interesting that you can plug different language models, GPT-4, GPT-3, name them. You have state, so it can keep state between prompts, etc., etc. And soon you will have a Java API for that. So hopefully, in a few weeks, months, we will be able to publish first release, a 0.1 maybe, and in your Java code you will be able to invoke, just have an OpenAI key or Azure OpenAI key. You have your endpoint, and that's it. You can, in a very easy way, the API is a fluent API kind of thing, and very easy. In your Java code, you can invoke AI.
So you have to start a JCP process, JSR, Java specification request.
Oh my God, this landscape is moving so fast that I'm not sure it will be ever standardized.
Why not? A string in, this is the input, and and list of strings out. This is the output. This would be the JSR. So we are
but when we looked into lately AI has boomed. And for the last years, the only examples that we see out there are mostly Python.
Yeah.
And the Java developers are, okay, well, I have to learn Python now, which is okay, but, And keep an eye.
But the strange thing is, this is not even in Python, right? Because the model is not Python. So Python loads binary. This is to my knowledge. So you could absolutely do it with Java. And what I always, thought, if you do it with Java, it should be a way faster, because Java is way faster than Python. So I actually, it's a very good idea. So what we are saying, this semantic kernel is, I get a Java API where I can call an already pre-existing model, ChatGPT-4, let's say, and I can pass, some arguments. The state is maintained for me, so I get my conversation scope again with CDI.
Yeah. Exactly, good old convention.
Yeah, exactly. Scope. So we can actually pick up the old 15 years old talks and say we are back in the game. We have conversation scope with AI.
Conversation scope, I love it.
Conversation, yeah. We should talk about it, right? So we are from JSF to AI. Conversation scope rocks. This would be the title of the next session.
Let's do a talk together.
Yeah. Something like a session. It remains your state, and you can write chatbots in Java. You could expose this as Quarkus, and great idea actually.
That's actually what I'm working for as a side project. I'm trying to have Quarkus, maybe who knows later, a Quarkus extension on semantic kernel. It's still fresh. Maybe next year I'll come back to the podcast to talk about it.
Yeah.
But it's really interesting. So if you are a Java developer, of course, if you listen to this podcast, and if you are a bit curious about AI, semantic kernel will have a Java API really soon. And even if this landscape is moving at a pace you can't imagine, the APIs are getting refactored. Once it's settled in a couple of weeks, it will be quite interesting to play with.
Very good. So shortly before the podcast, I will send you a boots with a steel cap, so nothing happens to your nails. Then we have the episode for sure. It was lots of fun, and we covered actually all the relevant, the most popular, I would say, Azure services, I would say, and even some AI stuff, right?
2023,
Of course. So I really would like to have you back with your experiments with Quarkus.
I will. I'm still working when I don't sleep on updating my Quarkus 3 books. God knows when it's going to be published, but yeah, I'd love to.
Thank you. See you soon.
Bye-bye, Adam. Bye, everybody. Thanks.